Today, I'm going to explain problem 19 from the Amc 10B of 2019. I'm just going to read the problem out loud. Let S be the set of all positive integer divisors of 100,000. How many numbers are the product of two distinct elements of S? Alright, so now that I've read it, we just basically have a number, 100,000. It's a nice 100,000. We can split this into two prime numbers being multiplied with powers. This is 2 to the 5th power times 5 to the 5th power. Since there's two numbers being multiplied together, then that means you multiply it again. So 100,000 squared is equal to, well, when you square both of these, you get 2 to the 10th power times 5 to the 10th power. And according to the number of factors trick, we can do 10 plus 1 times 10 plus 1, because those are all the powers, they're the same. This is 121. Now, you might think that this is the correct answer, but there are actually 4 cases that are wrong. This is what the question is really asking you. It wants you to think about the incorrect cases. We want distinct numbers, but sometimes they aren't distinct, like 2 to the 0 times 5 to the 0. This has to be 2 to the 0 times 5 to the 0 times 2 to the 0 times 5 to the 0th power. These are all the same, so they're not distinct. I think I wrote that a little squish, but our second case is something like that. 2 to the 0th power times 5 to the 10th power, when this can be written as 2 to the 0th power times 5. Well, this is wrong because it can't exceed 5, but 2 to the 0 times 5 to the 5th power. This is also wrong because these are two of the same elements, and this 10 power can be moved in this one, giving us another wrong case where 2 to the 10th power times 5 to the 0th power. This have to be written as 2 to the 5th power times 5 to the 0th power times 2 to the 5th power times 5 to the 0th power. This is also wrong. We have our fourth incorrect scenario, where it's 2 to the 10th power times 5 to the 10th power, where it's written as 2 to the 5th power times 5 to the 5th power times 2 to the 5th power times 5 to the 5th power. These are all wrong because they want distinct elements, not the same elements, where you can all write these as squares. So we have four incorrect possibilities. Well, not possibilities, just 4 incorrect multiplication of elements. So 121 minus that 4 is going to give us our correct, all our correct solutions, or 117. So that is our answer.